Hey guys. Okay, Unit 8 for chemistry involves equations, and we will be talking about balancing equations first of all, then types of equations, and we'll talk about 5 main types there, and then we will talk about writing equations either from a word description and putting them into a formula system with all of the symbols and whatnot, or taking the symbol format and putting it back into sentences. Also in this unit, we'll do our first lab in a while. I know it's been a long time, and just looking at some different reactions. So it's kind of a short unit, but it's one of those kind of like the mold that we just finished up, that you need it for a lot of other things. And so, we kind of have to work it in. So here it is. And we do it now because you have, you know how to name compounds, you know how to write the formulas for compounds. And so it's a naming thing, but also in the next unit, we will combine it with mole problems and some other calculations. So it works in here in the right time. So if it feels random to you, there is a reason to all of this. Okay, so here we go. Equations. So first of all, when you are balancing an equation, you have to remember the law of conservation of matter. And that basically is saying that matter is never created or destroyed, it only changes form. You've heard that a million times. And in chemical reactions, this is proven essentially because the number of atoms that you start with is the number of atoms that you end with. The mass is the same, as long as you can measure it. And that doesn't always happen, but the mass would be the same if you could measure every single thing. And then the charge on each atom is conserved. So if it's a +2 to begin with, it will be a +2 to end with. There are some exceptions to this, and if we get to it at the end of the year, we'll do what they call reduction oxidation or oxidation reduction reactions, redox, where that whole charge thing we'll have to kind of revisit. But for the most part, in a chemical reaction, what you start with is what you end with, even if it looks different. Okay, so here we have a typical reaction, and so I've got them color-coded just so it makes it a little bit easier, but what you see in the red, what you start with, those are known as the reactants. So those are your starting elements or compounds, your starting components, and they react to form the products. So there's one product here, but there can be multiple products. Just kind of depends on the reaction. In a forward reaction like this one, the arrow always points to the products. Some of the other numbers that you will see, or some of the numbers that you see in this equation, first of all, the big numbers in front, those are coefficients, and those we will talk a lot more about in a minute because they are what you would use to balance the equation, what you're going to use to make what's on one side of the arrow equal what's on the other side. The subscripts you're already kind of familiar with. Those are numbers, the little numbers that we put on there, and they are in compounds used to balance out the charges, or they are written because we know what the prefixes tell us as far as covalent compounds go. We'll talk about the 2's on the H and the O there because that is kind of a different one for us, but we'll get to that in a minute. And then the last one, the state of matter. So I've got the G's over here with the H and the O, this L for the H2O. That tells me that I have hydrogen gas and oxygen gas, and it reacts to form the liquid form of water. And so I could put symbols for that, and S, of course, would be a solid. And so it basically gives you kind of a shorthand version of the reaction. Now, the big thing for us at this point, because we're going to start with balancing, is that what you start with, the reactant amounts, are equal to the product amounts. And so that equation down below, it is balanced, but I just kind of want to show you how it is balanced based on the numbers and kind of what you do with them. And then we'll get to some practice on that. Okay, so if we start with our carbons, on the reactant side of the carbon, or excuse me, on the reactant side of the reaction, there are 6 carbons, okay? And then over on the other side, the 6 is in front of the whole compound, so it goes to everything behind it, which means I also have 6 carbons here. The H's, I have 12 H's over here as a reactant. And then on the product side, this 6 and the 2 multiply. 6 times 2 is 12, so there's 12 H's. And then the oxygens. So on the reactant side, I have 6 to start with here, plus these other oxygens here. 6 plus 12, because I have 2 times 6 gives me 12, and then plus the first 6 gives me 18. And then over here, same thing. I've got 6 times 2 is 12. And then 6 times 1 is 6. 12 plus 6 is 18 O's. All right. And so that's really pretty much all there is to it. The balancing practice that we will do in class and together, and you guys will do kind of on your own, are all based on this concept of the law of conservation of matter. What you start with is what you end with, and our job is going to be just to equal it out. Okay, so here's some practice. We're going to do this together in class, and you'll put these in your notebook. But big thing to remember when you are balancing equations, you only use coefficients. Okay, that means that you can only put numbers in front of the compounds. You can't add in subscripts. You can't put numbers behind. You can't, wedge them into the middle of a compound. On this page, and on most of the ones I give you for balancing, you will only put numbers in the blanks that I give you. That's why I put the blanks there. Okay, so starting with that first one, we'll do at least a couple. Use basically just a back and forth thing. So in that first one, I have 1 zinc here and 1 zinc here. So I've got 2 zincs, zinc, zinc, and then so that's all good. I'm going to leave them alone. Then my O's, I have 2 O's here and only 1 here. The only place I can put the number to get the 2 O's is in front, and it has to go in front of the whole thing. So I have a 2 there, which messes up my zincs. So now my O's are good. I've got 2 O's on each side, but now I've got 1 zinc to start with and 2 zincs to end with. So I have to come back over here and put a 2. And that's it. That one, granted, is really pretty straightforward and simple. They can be much worse than that, but that's the basic concept, just a back and forth until you get everything equaled out. If you want, it always kind of makes me feel better to make sure my blanks are all filled in. If you put a 1 there, it changes nothing, but you kind of know that you've checked it. Okay, so the next one, I've got 1 H to start with. Always do individual. I just go down the row usually. There's some tips and some like little tricks to balancing that we'll talk about, but in general, just start at the beginning and go on down. I've got 1 H to start with, 2 H's here, so I know I have to go back over here and put a 2. So now my 2 H's and 2 H's are good, but now I have 2 I's to begin with because the 2 goes to everything behind it. But on the other side, I also have 2 I's, and so that one is now balanced. I can put a 1 and a 1. Okay. Number 3, I'll go ahead and do that one. So I've got 1B here and 1B here. So all good there. But now my fluorines, I have 2 and a 3. So to me, the best, the easiest way to figure this out is to think of the lowest common multiple. I don't know if that's the right math word or not, but we're using it. So what's the most common, the lowest common number between 2 and 3 is 6. So if I want to get 6, to start with over here with my F2s on this side, I would multiply that by 3 to get 6 Fs. And then on the other side, I would multiply it by 2 to get 6 Fs. And so Fs are good. I've got 6 on the reactant and 6 on the product. But now I've messed up my B's because I had to put this 2 in front, which now means I've got 2 B's there. So I have to come back over here and put a 2. All right. Everybody okay with that one? So yeah, so do the other 2, go through them if you need to, and then, like I said, we'll be doing them in class. Okay, so now types of reactions. There are, these are the 5 common ones. You could probably break them down into different categories, different things, but these are ones that that I like, so we're using them. Okay, so first off, composition. These are sometimes called combination reactions or synthesis. I'll probably use those words interchangeably, but composition is when you have two or more substances, either single elements or compounds, that react to form one substance. So in this reaction, you have sulfur plus oxygen gives you sulfur dioxide. So two things form one thing. That is combination or composition or synthesis. See, I already used a different word. Okay, then decomposition is just the opposite of that. You have one substance, a compound, that breaks down into two or more simpler substances. So it can be, again, it could break down into single elements, or it can break down into smaller compounds. But in this one, you have calcium carbonate, and it's going to break down into calcium oxide and carbon dioxide. And so you have just the reverse of the composition, of course. And when we do our lab for this is part of what we're going to be doing is figuring out the different reactions, you know, writing them out, balancing them, all those kinds of things, actually mixing the chemicals and seeing what happens, but also determining the type of reaction. Okay, so third type of reaction, single replacement. In a single replacement reaction, you have a single element. Okay, so in this case, you have zinc, and it is going to replace something in the compound. So if you look and see what happens, you end up as a product some hydrogen, and notice now here's that zinc, but it's in the compound. So the zinc has basically kicked out the hydrogen and taken its place. So the hydrogen is now the single. Okay, so when you're looking at reactions, if you see a single element as a reactant and then you see a different single element as a product, you've got single replacement. Okay, two more. Double replacement. In double replacement, you're going to start, you have four different compounds, two reactants and two products, and they're all compounds. And in the reaction itself, the metals, and this again, you can reword this in all kinds of different ways, but the metals trade places. So notice on this, you've got silver nitrate plus potassium chloride. The Ag and the K are on the other side as a product, are now in different places. So they have swapped the metals out and just flipped them so that now you form two new compounds. Okay, and then the last one, combustion. This is a burning reaction. This little triangle over the arrow is representing a cute little flame. And so in combustion, you always have some kind of carbon-hydrogen compound, so that's what the CH4 is, in the presence of oxygen. It burns, or you heat it strongly, and you will always produce the same two products, carbon dioxide and water, so CO2 and H2O. So one of the things we'll do when we balance our equations is I will ask you to tell me what the type of reaction is. So if you kind of follow these patterns, look at what's happening, then you'll choose one of these five. Okay, so now writing equations. So now what if you have the words, you have a description, and I want you to put it in the equation format. You've got 5 steps. First of all, you have to write the correct formula for each reactant and each product. This goes back to being able to following our naming unit that we did a couple of units ago. So knowing the polyatomics, checking the charge on things and balancing those out, knowing what the prefixes stand for, all of that stuff, like that, basically that whole unit. Number 1, write the correct formula. And some exceptions to that are what are called the diatomic elements. There are 7 diatomic elements that naturally always come in twos, like they're not alone in nature. And so I have them listed here. They are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Now those 7, I'm going to have you write them on your periodic table. We'll mark them. I don't want you to forget them. I taught you, I think most of you, when you were freshmen, and we called these the Brinkelhoffs. So if you rearrange those letters, you can make, you know, our super cool word, Brinkelhoff. And so the Brinkelhoffs can't go anywhere alone. They always have to have a partner. Okay, so then you add the symbols if you know, or if you're given the states of matter. The four main ones are for a gas, a liquid, a solid, so G, L, or S. And then probably the most common if we're dealing with solutions is AQ, and that means that it is something that is dissolved in water. And so I'll have to give you that information, or you'll have to know it if you want to be able to label them. All right, some other symbols. If in your description it says yields or produces or forms, that's your arrow. It's like your equal sign. A plus sign takes the place of an and, or combines with, or reacts with. And then, like I've already told you, that little triangle means you need some heat. Okay, next step, we won't deal with this as much, but in a lot of chemical reactions, there is a catalyst that is needed. And a catalyst is a substance that speeds up a reaction, but doesn't become part of the reaction. So it is not ever in the products. It's never in the reactants either, but it is part of the reaction, basically a place for the reaction to happen. And if you do have a catalyst present, then you write the symbol over the arrow. And so if, for example, zinc chloride is the catalyst, then over the arrow, which you would put its symbol, ZnCl2. Sometimes it'll just say a catalyst is used, and then you'll have your arrow, and you'll see CAT over it. So it just is telling you catalyst happened. And then the last step is to balance. So that's the back and forth, and make sure you're equal on both sides. So here we go. Here's an example, and so I'm going to want you to write the symbols out. So write it out like an equation. When heated, magnesium reacts with oxygen gas to form solid magnesium oxide. Okay, so when you start, the very first thing it tells you is that when heated, and so you know that your arrow is going to have a triangle over it. So then when heated, magnesium, single element, you don't see the IDE ending, you don't see any 8 ending, so you've just got magnesium. The symbol for magnesium is Mg. Anytime you write a single element, you need to stop and think, is that part of Brinkelhoff? No, it is not one of the symbols. You don't hear it when we say the word Brinkelhoff, so I don't have to put any 2's with it. There's nothing, it's just magnesium. Now, I don't give you the state of matter on here, but with any single element, you can look at the periodic table and determine solid, liquid, or gas. All of the elements that have black letters on the periodic table in our room are solids. And so, and again, I know your periodic tables don't, the ones that I gave you, but if you're able, then you can go ahead and tell me that this is a solid. Okay, so magnesium reacts with, there's the plus, reacts with oxygen gas. Okay, so oxygen, of course, is O. So another single element. So in your mind, run through Brinkelhoff. Is O in there? Yes. And so I know that it needs a 2. And then I tell you it's a gas. So you put a little G there. So now I've got my reactants. Magnesium plus oxygen forms. So the 2 form is the arrow, but we've already got that because we did the triangle. 2 form solid magnesium oxide. So Mg, magnesium oxide. So when you write a compound, you've got to go back to the whole, all of the naming stuff. Mg, remember, is a +2. O is a -2. So that one's good to go. I don't have to do any extra balancing or add any coefficients, or excuse me, subscripts. Okay, and then last but not least, it tells me it is solid. Okay, so now we're basically through step 4 up there. So now our last step is to balance the equation. Okay, so start at the beginning. So just like we did a couple of pages ago, now you're going to add coefficients and coefficients only. So start with Mg. You've got 1 Mg. You've got 1 Mg over here. So good to go. leave that one alone. We'll have to come back and fix it in a minute. And then O's. I've got 2 O's here, but just 1 O on the product side. So I have to add in front of the whole compound. I can't do anything. I can't add any subscripts now. I can't do anything to change that compound. I added 2. So I know that my oxygens are balanced, 2 and 2. But I messed up my mg's. So now I've got 2 mg products. So I have to come over here and put 2 mg in the reactants. Okay, and then this oxygen just stays the same. So again, you can put a 1 in front of it if it helps you kind of make sure you've got everything kind of figured out. Okay, so step by step, you work through them that way. All right, so here is another example that we will do in class together, but I will do it here too. So same setup. Sodium chloride reacts with a solution, sodium chloride crystals, excuse me, react with a solution of silver nitrate to form aqueous sodium nitrate and a silver chloride precipitate. Lots of words in that one. So start at the beginning. Sodium chloride. Sodium chloride is salt. So NaCl. It's a +1 -1, so I don't have to add any subscripts. I don't have to do anything. It's already balanced. Then it tells me that they are crystals. That's a solid. Reacts with plus a solution of silver nitrate. Silver is Ag. It's +1. Oh, that looks bad. Nitrate is NO3, a polyatomic, a -1. So I've just got a +1 and a -1, so it's all good. The solution part. Solution means AQ. Okay. To form, arrow, aqueous sodium nitrate. So NaNO3. Again, a +1 and a -1. Oh, sorry, my eye itches. And that aqueous is telling me that I need another AQ here. And, oh no, I'm running out of space. And there's a plus, a silver chloride precipitate. So Ag for silver, +1, Cl for the chloride, -1. So +1, -1 again. So I don't need to add anything else. And the precipitate part, that is another fancy word for solid. Okay? So that one is all good as far as getting it written. I've got my symbols. I've got the compounds individually balanced by their charges. Let me put a +1 over this and a -1, a +1 and a -1 just so you see it. And then balancing. So if I'm going to balance this, I've got 1 Na and 1 Na. So that is all good. I have 1 Cl and 1 Cl. That is all good. I have 1 Ag and 1 Ag. That is all good. Now, the NO3, you can balance individually, the N's and the O's, or if the nitrate stays together on both sides of the arrow, you can balance it as a group. And so I have 1 nitrate and 1 nitrate, or we could have said 1 N, 3 O's, 3 O's. So this one was already balanced. I would, if you were putting in the coefficients, everything has a 1 in front of it. Okay, and so that is writing and balancing. Okay, now one more. So what if you have, oh, my arrow's in the wrong place. What if you have the equation, but I want you to write a sentence? So it's basically just the opposite. So here it tells you to balance and then write a description or a sentence for each one. So if we balance it first, just for some practice, I've got 1 Al and 2 Als. So let's go back and put a 2 here. Then I have 1 Cu and 1 Cu. And then I have 1 SO4, and on the other side, since I have SO4 staying together, I'm going to balance it as a group. I've got 3 over there. So my SOs aren't balanced, so I need to put a 3 here. And that has changed my CUs, so I have to put a 3 here. And that should be good if I just put in a 1 there to remind myself. All right, so now the balancing has nothing to do with the next part. I just kind of wanted to do for practice. But if we are writing this sentence, and I apologize because I know my writing's probably going to be kind of messy on this page, but you just write the words for what's written down. So you could say solid aluminum reacts with copper to sulfate. Okay, copper is a Roman numeral. SO4 is a -2, so copper has to be a +2. That's where the Roman numeral comes from. So solid aluminum reacts with copper sulfate. With copper sulfate solution to form. So there's my arrow, to form. You can say aqueous or a solution of. So aqueous aluminum sulfate and solid copper. And that's it. Okay, everybody all right with that? And then one more. So balance this one. You've got silver oxide reacts to form oxygen and, silver and oxygen. So 1 Ag and 1 Ag, 1 O, 2 O's. So I've got to put a 2, a 2, and a 1. So there's just some practice balancing on that one. And then the description of this, you would say something like, let's say silver, oxide, let's see, a powder or crystals, or silver oxide solid. When heated, put my comments in the right place, when heated, forms solid silver. Sorry, it's getting even messier. Solid silver and oxygen gas. Okay, and that is it. Now, the one thing we didn't really practice a lot on, which we will do more in class, is the types of reactions. So look back over those 5 types, make sure you've got that, and as always, ask me questions, please. All right, talk to you guys later.